So I think this is shared with you also, and in the classroom everything is there. So these are the formulae which we will be using in the Z transform. Yes. So like I think last time I have started from the inverse transform, where Z transform expression you have to just get it reverse way, and that will give you the original sequence. So if Z is given to you, means a function of Z, and you are asked to calculate f of k. Okay, so these are the few expressions frequently we need it in the inverse calculation. So maybe that is the first one, which is z upon z minus a transformed, whose answer will be a raised to k either or minus a raised to k, depending upon the range for k, whether k is less than 0 or whether k is greater than or equal to 0. Okay. So that way, an answer will be a raised to k into uk, unit step function. It is one and the same. That is z upon z minus e. Similarly, these are the few expressions, but we are hardly using that. Z square upon z minus a square, z cube upon z minus a cube, and all. Are you writing this or it is there in front of you? Yes?
Ma'am, we are writing.
Madam, we are writing.
Okay, okay. Done? Shall I move ahead?
Yes, ma'am.
Yeah.
Yes, madam.
So this is regarding
Yes, ma'am.
and these notes are of course available in Google Classroom. So you can have the access for this one. So formulae are there. Okay, so now in this inverse Z transformation, one method last time also I have introduced, that is a partial fraction method to get the answer for the original sequence f of k. And for that we need to split the fraction into parts. So maybe depending upon your denominator term, if it is containing the linear factors and non-repeated linear factors, then accordingly you will be getting the answer for the fraction on the right hand side. Similarly, if the denominator contains the repeated linear factors, that uh, that type of the fraction will appear on the right hand side. Okay, so these are few expressions which are solved here, and when you will use that partial fraction method, that is depending upon your fraction. When the denominator's degree is more than numerator, always will go for this partial fraction form. If it is equal, or if numerator's degree is more than denominator, then we will first of all go for the actual division. We will bring the given expression into that proper fraction form, and then we'll apply the partial fraction. So here is the first example which you can write down. That is, find the inverse Z transform of Z upon Z minus 1 into Z minus 2 if modulus of Z is greater than or equal to 2. So since denominator contains two factors and both are the linear factors, they are non-repeated. This is your denominator. Okay, denominator is containing linear factors and non-repeated, means not same. So we are going to take the given fraction into two parts, and for that the first step is always consider this fz upon z. The given fraction is containing z in the numerator, that is brought here in the denominator, and make it right hand side as 1 upon z minus 1 into z minus 2. And now applying the partial fraction method, क्योंकि numerator की degree is now 0, denominator's degree is 2. So certainly denominator degree is more than the numerator. And left side is fz upon z. So how to write this fraction? That is a upon 1 factor z minus 1 plus b upon the second factor z minus 2. And now our intention is to get the values of a and b with the help of two values of z. Okay, so next step is numerator of the left hand side. This 1 is the numerator of the left hand side, and right hand side numerator is a into z minus 2 plus b into z minus 1.
Ma'am, your voice is breaking.
LCM is z minus 1 into z minus 2. Will you please mute all of you, because somewhere the noise is coming? Yes. So our fraction is now a upon z minus 1 plus b upon z minus 2 is equal to 1 equal to left hand side numerator equal to the right hand side numerator, that is a into z minus 2 plus b into z minus 1. Now this is suggesting us that two values of z you have to put it. Okay, so two values you can start it from the least value like 0, 1, 2, minus 1, minus 2, etc. Only our purpose is to get the answers for a and b. So we need two equations in a and b. And in that case, here this is very easy because z minus 2 means if I put z equal to 2 here, that coefficient of a becomes 0 and I will get the answer for b. Similarly, if I put z is equal to 1 here, this expression, b into z minus 1, if I put z equal to 1, then the coefficient of b will be 0 and I will get the answer for a. So this is what it is done here. Put z equal to 1, and therefore 1 left hand side 1 is equal to a into 1 minus 2, that is minus a. So you will be getting the answer for a as minus 1 and b is equal to 1 by putting z is equal to 2. So your fraction fz upon z is minus 1 upon z minus 1 plus 1 upon z minus 2. And therefore, this is, now we want answer for fz. So now you bring this z again on the right hand side. So it will come to the numerator. So fz is equal to now z minus z upon z minus 1 and plus z upon z minus 2. So now this is in the standard fz form. So now you have to consider the inverse, both sides. So left hand side inverse, that is z inverse of fz, is equal to right hand side minus sign is taken out, z inverse of z upon z minus 1, and second term z inverse of z upon z minus 2. Okay, and which is by the standard formulae list. What is that? Z upon Z minus 1. You can either put it in the unit step function form or it is a raised to k form. Okay, in the formulae list you have written this is a raised to k. Z upon Z minus a. Answer is a raised to k for k greater than 0 and minus a raised to k for k less than 0. So the same thing it is done. In this case, inverse transform minus of 1 raised to k first term, second term 2 raised to k greater than or equal to 0 as this is given. This is given to you. Mod z greater than or equal to 2 and mod z greater than or equal to 1. For that we are having k greater than or equal to 0. And therefore final answer is 2 raised to k minus 1. That is the procedure for the partial fraction form. Following? Any doubt regarding this problem? So that I can share my pad and we'll do some 1 or 2 problems and then we'll go for the difference equation. Yes, any difficulty regarding this problem?
No.
No, ma'am.
Yeah.
No,
No,
ma'am.
madam.
Okay, good.
No, ma'am.
So you are
Ma'am, we are writing down, so.
writing?
Yes, ma'am.
Yes.
Ma'am,
Do-
just one request. We are going very fastly. We are writing simultaneously. So can you please means dictate little bit slowly?
Yes.
Just a little
No
bit.
issues. Yes. And wherever you want me to stop that particular step, you just say, so that I'll come to know. Because simultaneously you are writing, but as I'm telling again, this part is there available in the classroom. So these notes are already there. So while writing on the pad, I'm giving sufficient time. So
And please slide it little bit upward.
okay.
Done, madam. Thank you.
Okay. So let us see another example. I'll share my pad and we'll do on that. Yes, you can see now the screen. This is what we have done last time. A calculation for the inverses. Take down this example where we have to find out the answer for the inverse Z transform. Okay. Take the next example as such. Find inverse Z transform of Z cube upon Z minus 1 into Z minus half square for mod Z greater than 1. Now this is to be identified. What is your original sequence? Okay. So here, first of all, we will take the step fz upon z and then we will apply the partial fraction. What is the degree of the numerator? What is the degree
3.
of the 3 and denominator is degree?
2.
Denominator's degree is also 3. 2 plus 1. There is a quadratic factor and linear factor. Correct?
Yeah.
Let us
Yes,
take
ma'am. Yes, ma'am.
first step as fz upon z. So one of the z term you bring it in the denominator of this and make this term as z square upon z minus 1 into z minus half square. Okay, this is just one z. I have taken it in the left side of the denominator and right hand side made it numerator's degree is now 2, denominator's degree is 3. So you have to write down the fraction. Therefore, z square upon z minus 1 into z minus half square equal to. Now, how do you write the fraction form on the right hand side, partial fraction? How do you write the partial fraction form on the right hand side? There is one linear factor z minus 1, which is non-repeated. And there is another factor z minus half square. Square means repeated. This
Z
factor
minus
is
1,
repeated.
Z minus half and Z minus half, that we will split, and then we will write A upon Z minus 1 plus B upon Z minus 1 by 2 plus again C upon Z minus 1 by 2.
But one z minus half will be
Square will be there.
square. So plus b upon z minus
Yes.
half. Yes, because this factor is repeated. So we have to write down this as c upon z minus half square. Are you getting? This is a fraction form. For second factor is repeated. So I'm getting b upon this, c upon this is square. And now equate the numerators of both sides. Therefore, numerators from both sides, that is left hand side numerator is z square, is equal to right hand side a will be having the coefficient z minus half square, correct? Plus b will be having the coefficient z minus 1 into z minus half. And C will be having the coefficient Z minus 1. Am I right? Any doubt here? You can write the LCM of denominator's LCM will be Z minus 1, Z minus half square. So the term which is not available in the first fraction denominator, that is to be multiplied. So Z minus half square term, which is multiplied with A. B term is multiplied with Z minus 1 and Z minus half. And C term is multiplied with Z minus 1. Any doubt?
No, ma'am.
Good. So now you have to put 3 values for Z and get the answers for A, B, C. That is the next task. So first one suggesting me that put Z is equal to 1. Then you can put Z is equal to half. Then you can put any other value because 2 values it is suggesting from the factors. I can put Z is equal to 0. Any other value you can put which is the least one. Okay. So if I put Z is equal to 1, B coefficient, C coefficient will be 0 and I will be getting the answer for A. So left side 1 square is 1. Right hand side A into bracket 1 minus half square. Rest of the part is 0. So that is half square means 1 by 4. So what is the answer for A? What is the answer of A? A is 4. Similarly, if I put Z equal to half, A coefficient and B coefficient will be 0. And I'll get the answer for C. So this is half a square left side. is equal to C into half minus 1. So tell me what is C?
-1/2.
Yes, it is minus 1 by 2. And now if I put Z equal to 0, then left side is of course a 0. Right hand side it is A into 1 by 4. Correct? 1 by 2 ka square plus B into 0 minus 1 and 0 minus half, that is half. And plus C into 0 minus 1 is minus C. And now you have A and C answer, so you can get the answer for B. Can you tell me what is B?
-1.
Is it minus 1? Check it again.
-4.
-1.
See, if A into 1 by 4 plus B into half minus C you are getting. Now C is minus half, so it will be plus 1 by 2.
Oh, +1.
Four.
+1.
Minus 1. Sorry. Sorry.
Three.
Hmm? No, minus 1 is also not correct.
-3.
Minus 3, that's correct. So B is minus 3, C is minus half, and A is 4. Put it in the fraction. Okay, we'll call this as 1. This is 1. Okay, this is together, and we can put it here. Therefore, 1 becomes Fz upon Z is equal to A upon, that is 4 upon Z minus 1. Minus B is 3, minus 3. So minus 3 upon Z minus half. And C is again minus half. So minus 1 by 2 upon Z minus half square. And now shift that Z on the other side. So we will be getting Fz. Therefore, Fz is equal to 4 into Z upon Z minus 1. You can write like this. Minus 3 into Z upon Z minus half. Minus half outside I'll take Z upon Z minus half square. Right? This is Z minus half square, and the range is given for this problem is modulus of Z greater than 1, ROC. Okay, where mod Z is greater than 1. This is given to you. And therefore, now left hand side, both sides inverses we have to consider. Therefore, Z inverse of Fz left side is equal to, you can take this 4 outside and take the inverse transform of only Z function. Minus 3 into Z inverse transform of Z upon Z minus half. And minus half Z inverse of Z upon Z minus half square. For mod Z greater than 1. So left hand side is of course f of k. Inverse transform of Z is f of k. Right hand side, please see the formula. What is Z upon Z minus a? Formula inverse transform. What do you write first term? What do you write for this term? Whose speaker is on? Dinesh sir or yeah. Yes. Yes, Hemalata madam, now it is, I think, clear. Noise is not there. From my end, I am sitting in the classroom. Is it okay?
Yes, ma'am.
Yeah. So tell me, Z upon Z minus 1 inverse transform, what do you write? 4 into
1 raised to k.
1
1
raised to k. Very good. So that is 1 raised to k minus 3 will be as it is. Same thing. This is half raised to k. Correct? A is
Yes.
half. So this is half raised to k. And the third term minus half, inverse transform of z upon z minus a, the whole square, can be taken as k into a raised to k, k into a raised to k minus 1. So k into 1 by 2 raised to k minus 1. For k greater than 0, because your range is mod z greater than 1. So certainly it is greater than half, it is greater than 1, and therefore k is greater than 0. So finally, because this is the third term formula is only, you have to check it is there in the list or not, or otherwise you can add it using the inverse transform z inverse of z upon z minus a the whole square. If this is the term, then whose answer is k into a raised to k minus 1. For k greater than or equal to 0, if mod z is greater than mod a. We are using this for the third term. Okay. Third term ke liye we are using this particular form. So finally you are getting the answer for f of k, that is your original sequence. Okay. So this is how we are finding out the answers for inverse Z transform with the help of partial fraction method. One you can try here. Evaluate Z inverse of 3z square plus 2z upon z square minus 3z plus 2 for if 1 is less than mod z is less than 2. Okay, find the inverse transform of 3z square plus 2z upon z square minus 3z plus 2. Can you find the factors of the denominator in fz? Can you tell me the factors of the denominator?
Z
Z
minus
minus 1, Z minus 2.
1.
Yes, very good. So very simple quadratic equation is there whose factorization is z minus 1 and z minus 2. So you can write down fz is equal to 3z square. I can take z common and 3z plus 2 I can write. Denominator is z minus 1 and z minus 2. Simple factorization is there for this. Okay. So denominator contains two linear factors non-repeated. So you can perform the partial fraction form. Therefore, f z upon z, 1z I will take it here, and it can be written as 3z plus 2 upon z minus 1 into z minus 2. So now it is in the standard form you are getting. Split it into the two parts and tell me what is your partial fraction form. Fz upon z. What is the value for A? What is the value for B? Got it? A upon Z minus 1 plus B upon Z minus 2. So what is A and B?
Ma'am, is it -5 as A and B as 8?
Correct, correct. Very good. So that's the correct value. So A is -5. You're writing the denominator term as a Z minus 1. Then the answer for A, which is -5, and the answer for B is 8. That is perfectly correct. So -5 upon Z minus 1 plus 8 upon Z minus 2. And now next part is simple. Therefore, Fz is equal to -5 Z upon Z minus 1 plus 8 Z upon Z minus 2. Take its inverse both sides. So Z inverse of Fz is equal to -5 Z inverse of Z upon Z minus 1 plus 8 into inverse transform of Z upon Z minus 2. And our range is again given as modulus of Z less than 2 greater than 1. Correct? Modulus of Z greater than 1 and it is less than 2. That is the range given. Since 1 less than mod Z less than 2 implies mod Z is greater than 1 and mod Z is less than 2. So how do you write the sequence? So left hand side का answer है f of k is equal to what do you write? -5 into what is that sequence? What is this answer? Sequence Z upon Z minus 1 inverse.
1 raised to k.
1 raised to k and second term Z upon Z minus 2, but in that case we have to consider this region of convergence mod Z less than 2 means mod Z less than a wala sequence you have to see. What is the answer for that? Just refer to the table. What is the answer for Z upon Z minus a where mod Z is less than mod a, giving which sequence? Which sequence it is giving? You have known the table, the first term which you have written a raised to k. So there are two columns for k greater than 0 and k less than 0. Correct? And k less than 0 will come for modulus of z less than mod a. So your answer for the second term will come out as -2 raised to k. Are you following?
Yes, ma'am.
Yes, ma'am.
So in the first step, this k is greater than 0. Second term, k is less than 0. K greater than or equal to 0 and this is less than 0. So ultimately, your answer will be minus. You can take both the terms negative anyway you are getting. So -5. 1 raised to k is 1 itself. You need not have to treat it differently. So 5 you can write down -8 into 2 raised to k. That's your sequence. Okay. This is the sequence f of k. Okay. And one more I'll just show you, that is regarding the cosine and sine function also we have done. So based on that you can adjust the terms and get the result for this also. So next example you can take it. Find the inverse transform of z square upon z square plus 1 and show that this is equal to xk sequence. Show that this is equal to xk for mod z greater than 1 where xk sequence is nothing but cos of k pi by 2, k greater than or equal to 0. So actually this is very simple example and calculations are also very less for this particular problem. Okay, now as the question is for show that something and answer show that is in the cosine form. So what is your cos alpha k answer? Do you remember? What is cos alpha k transform? Since Z transform of cos alpha k is equal to Z into Z minus cos alpha upon Z square minus 2Z cos alpha plus 1. Do you remember? This is what we have written last time. Z transform, not inverse, Z transform cos alpha k. Okay, so whenever denominator contains some quadratic terms like this, Z square plus some linear term 2Z plus 1 or something like Z square plus 3Z plus 2 and etc. The terms you can think of whether can be converted into the cosine function, because in the cosine transform the denominator contains the quadratic term Z square minus 2Z cos alpha plus 1. Now only task for us is identifying that cos alpha, means what is that alpha, that is to be identified. Okay, so in this case also here f of z is z square upon z square plus 1. So can be written as this is equal to z into something z minus cos alpha form we have to write. So what do you write? Z minus cos of which angle? So that numerator only will remain as a z square. Cosine of which angle is giving you the answer 0. Yes,
Pi by 2.
pi by 2. So cos of 90 is always 0. So this we can write down as cos pi by 2 upon. Now what you have written numerator, same thing should be there in the denominator. So z square minus 2z cos pi by 2 plus 1. Correct? And this is 0. So we are getting the answer. So this answer z square upon z square plus 1 can be written like this. Z into z minus cos pi by 2 upon z square minus 2z cos pi by 2 plus 1. So therefore alpha is equal to pi by 2 and therefore your sequence will be, this is the answer for inverse transform cos k pi by 2, and therefore inverse transform of fz is nothing but inverse transform of z square upon z square plus 1, and which is nothing but z inverse of z into z minus cos pi by 2 upon z square minus 2z cos pi by 2 plus 1, and this is giving you the value as cos of k pi by 2 for k greater than or equal to 0. Followed? This is regarding the inverse transform and how to adjust the terms in the quadratic form when you identify that it is a cosine transform expression in the inverse case. Okay, so we are getting the answer with this particular term. So one homework example I'm just giving you along with this, and then I will explain you the difference equation. Okay, just to get the answer for the inverse transform. For this one, find inverse transform of z into z plus 1 upon z minus 1 into z square plus z plus 1 for mod z greater than 1. Okay, just like this, numerator denominator degrees 3, numerators degrees 2. So you have to split it into fraction form, and the second fraction, which is nothing but quadratic term, you are getting in the denominator. So for that we have to write down the fraction form and then simplify. So I'll just give you the hint. Accordingly, you just try to simplify. Fz upon z is equal to z plus 1 divided by z minus 1 into z square plus z plus 1. And therefore, this z plus 1 upon z minus 1 into z square plus z plus 1 can be written as, now first factor is a linear factor, so a upon z minus 1, and second factor is of course quadratic factor, but which you cannot split it into the linear real factors. Like in the previous case you obtained the factorization, but in this case the factors are complex number, so you cannot split it into the real factors. So keep it as it is and write the numerator as bz plus c upon z square plus z plus 1 for this particular factor. This is a quadratic, giving quadratic factor with complex roots. So we are keeping it as it is. And then you take the numerators from both sides, then find out the answer for A, B, C. That procedure is same. 3 values of Z you have to put, get answers of A, B, C, and then you can see how you can write down the second answer, second term answer, and how you can bring it to the cosine form, because denominator contains the quadratic term. Okay, just try. If you don't get, anyway we are going to solve it. Let's try one example for homework I'm giving. Now the main concept where why we are learning this Z transform is to identify the solution of the difference equation. So differential equations, many of you already have studied and you have calculated its a solution, which is the real calculus part. But here we are calculating the answer for the difference equation as we are working in the discrete system. Okay, so the last part of this Z transform is the applications of Z transform to the difference equation. To the difference equations. Okay, I'm not calling this as differential equation, but difference equation. So difference equation means the sequence given, then displaced sequence is given. So what is the value of f of k plus 1? What is the value at f of k plus 2? What is the value at f of k minus 1? And like that. So those things we are going to identify. So please write down this thing, a relation between f of k and f of k plus 1, comma, f of k plus 2, and etc. f of k plus 3, etc. is called the difference equation. It's called your difference equation. And the expression for f of k in terms of k is its solution. Therefore, f of k is its solution. Is its a solution. So we have to find out the solution for this by using the standard formulae in this particular form also. Okay, so useful, you can write down useful results for finding the difference equation, that is Z transform of f of k is equal to f of z, that is known to you. Similarly, we can take Z transform of f of k plus 1. Okay, f of k plus 1 displaced function is z into f of z minus z into f of 0. F of 0 is the value of the sequence at k is equal to 0. Where f of 0 means value of f of k at k is equal to 0. Similarly, Z transform f of k plus 2. F of k plus 2 can be written as z square f of z minus z into z square into f of 0 and minus z into f of 1. So like that you can continue. Again f of 0, f of 1 are the values at k is equal to 0, k is equal to 1. So useful results for the causal sequence k greater than or equal to 0. For that you can substitute this thing. Okay. And similarly, fourth one, z transform of f of k minus 1. So one step preceding step. So k minus 1, which is z raised to minus 1 into f of z. Similarly, z transform of f of k minus 2, that is z raised to minus 2 into f of z, and like that. Okay. So please using these results and of course the standard sequences answers, we have to solve the difference equation. So I'll just show you how to get the value for this one. For example, solve the difference equation f of k plus 1 plus half into f of k is equal to half raised to k is equal to half raised to k for k greater than or equal to 0 and f of 0 is given as 0. These are the things given. F of k plus 1 plus half into f of k is equal to half raised to k for k greater than or equal to 0. Okay. So now the first step is take the z transform on both sides. So take z transform on both sides. So we'll get z transform of f of k plus 1 left side plus half is constant z transform of f of k is equal to right hand side z transform of 1 by 2 raised to k. Okay, and this is to be obtained for k greater than or equal to 0. So now use the result for f of k plus 1. Okay, useful result I have given you this thing. Use the result. Z transform of f of k plus 1 is z into f of z minus z into f of 0. So this is first term z into f of z minus z into f of 0. That is the first term answer plus half of, what do you write, z transform of f of k?
F of Z.
F of z. Z transform of f of k is f of z. And right hand side tell me what I should write, half raised to k transform for k greater than or equal to 0. What you will get right hand side? What is the transform of a raised to k?
Z upon Z minus half.
Yes, very good. So that is just z upon z minus a. A is half here. Z upon z minus half for mod z greater than half. Mod half. It's one and the same. Now you put f of 0 answer is given as 0. Okay. So put it here and collect the coefficient of f of z. So f of z coefficient here it is z and here it is 1 by 2. So this is z plus half is the coefficient of capital F of z minus z into 0. F of 0 is 0. Right hand side is z upon z minus half. Okay, and therefore we are interested in what is our fz. So fz becomes therefore z upon z minus half into z plus half. Am I right? This is z minus half into z plus half. So now perform the partial. Perform the
हो
partial
आहे
fraction.
पण सांगत नाहीये ती कॉर्पोरेशनच्या मिळतील उद्या.
Please mute all of you. Manisha madam. Smita madam. Manisha madam. Smita madam, please mute yourself. Okay. So now apply the partial fraction form. So next task is to get the inverse Z transform. Okay. And therefore we can write down this as Fz upon Z is equal to 1 upon Z minus half into Z plus half. So split it into fraction and find its inverse. So that means 1 upon Z minus half into Z plus half can be written as A upon Z minus half plus B upon Z plus half. So what do you get? A and B answers? That means 1 is equal to A into Z plus half, numerators from both sides, B into Z minus half. So two values of Z are half and minus half. You can put and get the answers for A and B. What do you get? A and B?
A as 1 and B as -1.
Yes, very good. So this is 1 upon Z minus half minus 1 upon Z plus half. And take its inverse by shifting Z on the other side. Therefore, inverse transform of Fz is equal to inverse transform of Z upon Z minus half plus, sorry, minus Z inverse of Z upon Z plus half. And it is once again Z upon Z minus A form. So using Z upon Z minus A inverse transform, Z upon Z minus A, which is A raised to K for K greater than or equal to 0 and mod Z greater than mod A. And the answer is minus A raised to K for K less than 0 when modulus of Z is less than mod A. Okay, so using this or keeping it in mind, we'll get left hand side answer is f of k is equal to inverse transform, that is half raised to k. Okay, so our range is given as mod z greater than half. This is given. Mod z is greater than half. So certainly it is greater than minus half. Correct? No? When it is greater than half, it is greater than minus half. And therefore answer is half raised to k first term minus second term, that is minus half raised to k for k greater than or equal to 0. Have you followed? This is the final answer. So answer is the solution, that is f of k. So here we are doing two things. We are finding pile z transform and then we are finding its inverse transform to get the original sequence, that is f of k. Any difficulty for this example? Anywhere not followed? Okay with you?
Understood, ma'am.
Yes.
Yeah.
Okay.
Yes, ma'am.
So we'll take one more example here with the difference equation. Take this one. Find the solution of this difference equation 12 into f of k plus 2 minus 7 into f of k plus 1 plus f of k is equal to 0 for k greater than or equal to 0 and f of 0 is 0, f of 1 is 3. F of 1 is 3. This is given. Okay. So quickly, can you tell me what is the answer of your fz? Take z transform of the given equation, put f of 0, f of 1 answers there, and tell me what is the answer for fz, capital Fz. Then we'll go ahead to take the inverse transform. So just try and tell me what is fz.
Ma'am, can you please share these notes? Is it possible, madam?
Yeah, it
On
is already,
Google Class?
the notes are already shared in the classroom. The inverse transform also it is there, Z transform and inverse transform. Only thing, the examples which I'm taking here, maybe one or two different examples are there. These notes, that
Okay.
recording anyway, I'm sharing, no, this thing.
Yes, yes, madam.
Hmm?
Yeah, yeah. Thank you.
And notes also I will share. What I will do today, last time also I think I have told to you, I'll form your group separately for maths. And in that I'll share the material, okay? The study material. I
Yes,
think
sir.
all of you are
That will be
comfortable with WhatsApp. So instead of uploading there in the classroom, it is already there. So I'll be uploading in the WhatsApp group also, okay? In that, it will be easy for you to
Yes,
access.
because in a common group, madam, there are so many courses are
Yes,
going
yes,
on
other
and so many
teachers are also there,
other
other
materials are there, so it will
notifications are
confuse
also there,
for
so it is
all of us.
better. I'll form your group and I'll ask you to join that link so that in that I can send you the material, study material.
Yes, madam. Thank you. Thank you.
Anybody got the answer for FZ? No? Hmm? Take the Z transform both sides first of all of the equation. That is Z
Is it
transform.
12 upon Z?
Only 12 upon Z you are getting.
Yeah. Yeah.
No, no, no. There are other terms, no? F of k plus 2, k plus 1. F of 1 is given as 3.
Okay.
You have to make
Gotcha.
use of that. These two terms. So this is Z transform of 12 into F of k plus 2, first term, minus 7 is common, you can take it. Z transform F of k plus 1 and plus Z transform F of k. Now here one advantage is that right hand side 0 is there. So no transformation on the right hand side, it will be as it is 0. And here you can use the useful result. So 12 constant outside and this term transformation can be written as Z square into F of Z minus Z square into
Minus
F of
Z
0.
0 minus Z into F of 1.
Yes, very good. So that's the first term. Minus 7 into Z transform of F of k plus 1 is Z into F of Z minus Z into F of 0. Correct? And the last term transformation is just Fz, which is equal to 0. Now f of 0 and f of 1 is given. So you can put that f of 0 is 0, f of 1 is 3. So using that 12 into bracket, I'll collect fz key terms. Okay, so this is one term z square fz, then z into f of z and this z. So I'll take fz common and the coefficient of that is 12z square minus 7z plus 1. This is the coefficient of fz and the remaining terms. So minus 3z will be there. Sorry, 3 into 12, 36. 36z will be there minus 36z and any other term, this is also 0. F of 0 is 0. So this is only term. Means I'll get f of z is equal to 36z upon 12z square minus 7z plus 1. Is it correct? Can you factorize the denominator and tell me the factors? What is the factorization for denominator?
Z minus 3, Z minus 4.
Is it z minus 3, z minus 4? Is it giving the same equation? You see? I want first term 12 z square. Is it? Is it correct? 4z minus 1 into 3z minus 1. You know the factorization for the quadratic equation. 12 is the multiplication of the first and the last term. Middle term is minus 7. So that is giving me the answer minus 4z minus 3z, which is minus 7z. Is it correct?
Yes, ma'am.
No. So this denominator is a linear factorization and non-repeated factors. That means we are getting fz upon z is equal to 36 upon 4z minus 1 into 3z minus 1. And taking its inverse, first of all, you have to take the partial fraction form. Partial fraction form is 36 upon 4z minus 1 into 3z minus 1, giving a upon 4z minus 1 plus b upon 3z minus 1. And calculating the answers for a and b after equating the numerators from both sides, it is giving you answer for a is minus 4, answer for b is 3. So just verify. Okay, so this is minus 4 upon 4z minus 1 and plus 3 upon
रेग्युलर लेक्चर घेतो.
whose mic is on? Ashwin sir, please mute yourself. Ashwin sir. Ashwin sir, please mute yourself. Ashwin Sandore. Ashwin Sandore sir, please mute yourself. Lot of noise is there. Okay. So it is minus 4 upon 4z minus 1 plus 3 upon 3z minus 1. So please verify the answers for A and B, and therefore inverse transform of fz means this 4 you can keep it outside, or I can keep the first term positive. So 3 into the inverse transform of z upon 3z minus 1 and minus 4 into inverse transform of z upon 4z minus 1. Okay, so as the terms are containing 3 with this denominator z term and 4 here, so that is looking odd to give me the original sequence. So I'll adjust that right hand side with 3 into bracket inverse transform of, I can write down this as z upon z minus 1 by 3. Is it possible? Can I write like this? Is it giving me the same answer? Yes or no?
Yes, madam.
And which gives me
Yes,
the
madam.
inverse transform. Therefore, the inverse transform of this can be written as, and this is, of course, right hand side. One more 36 is there that I forgot to take it. So this is actually multiplied by 36. 36 into this thing. 36 is there no, in the numerator. That is to be taken. Okay, 36 will be here and z upon z minus 1 by 3. Then therefore 36 into inverse transform of z upon z minus 1 by 3 minus this 3 of course will be here. Okay, and 4 is also here. Not outside. You have to take it, otherwise it will not match. So this is inverse transform of z upon z minus 1 by 4. And that gives me final answer. Therefore, left side inverse transform is f of k. Right hand side inverse transform is 36 outside as it is. And inverse transform of z upon z minus 3 is 1 by 3 raised to k. 1 upon
dot.
1 upon 3 raised to
माहिती नाही
k.
पण बरोबर
First term
काय अडचण नाही का
minus 1 upon 4
कधी बनणार
raised to
आता
k.
उद्या भरू जमेन
For k
आपल्याला काय
greater than equal to 0.
आता नको पण आता
प्रिंट मारू शकतो ना सर म्हणजे
Okay.
आपण
Followed the example which is based on the difference equation. So you have to just put the values and simplify. F of 0, f of 1, whatever it is given, just apply there and simplify, find out the sequence. Okay. So one more example. I think one example already I have given you. Now only thing is that in this week I'm not available on Thursday also. I'm having the work, and Saturday of course is a holiday, so I won't be able to take any lecture in this week further. So we are going to meet in the next week only. And for that, now this is actually the completion of a Z transformation along with Z transform and the inverse transform with the applications in the difference equation. So I will be uploading the
Excuse me,
assignment,
ma'am.
first assignment based on this Z transform, whatever we have done. Okay, all of you see that in the Google Classroom, as well as I will form your WhatsApp group, and in that I will send you the assignment. But
Excuse
do
me,
it.
ma'am.
Hmm?
Ma'am, can I leave the meeting?
Yes. No, anyway, I have
Really,
finished.
ma'am, I'm
Hmm.
having very less battery, and also actually the light here it is the power cut. So
Okay,
I
madam, no
already
problem.
gave you. I already gave you my attendance in the chat box.
Yes.
Okay. Thank you.
Hmm.
Thank you very
Yeah,
much.
okay, no problem. So only thing is, please revise the things, whatever we have done. This recording also I'll be uploading in the classroom. That link I'll be sharing. Okay, YouTube link is there. And these notes which are there uploaded as the study material in the Google Classroom. I will be sending you the first assignment on the Z transform through WhatsApp as well as the Google Classroom पे upload करूँगी, and that you have to complete it and upload that assignment by next week. So I'll give you that due date also. Okay, so today is the Tuesday, so by next Thursday, because we will be meeting on next Thursday now. So by that time, you should complete and upload that assignment, first assignment. So I'll be starting with the next transform, Fourier and the Laplace transform. Okay.
Ma'am, also will you please upload the syllabus?
Yeah. Syllabus, I think it is there in the classroom. It's not there. I thought it is there. Okay. I'll see. Otherwise, I'll send you the
madam,
link.
it is not there.
Okay, I'll send
Madam,
you the
would you please
lesson plan as such.
Would you please clear that as said last time, there are two classes for maths. One is PhD students maths class, and other is FOE PhD mathematics.
So you have to join FOE PhD. The first classroom.
That is created by Vaishali Joshi, madam. Is that?
So let it be. Let it be. In that classroom only you have to add through that only, because there are material is available over there. So unnecessarily again I have to create the two different classrooms, and sending material is difficult for me. So please all of you join that FOE PhD students, PhD classroom. The other classroom, as far as possible, I'll try to remove. Otherwise, let it be, but you join that other one.
Madam, can you please provide Google Classroom code for that FOE class?
Yes, there only.
It is where it is, ma'am. It is on the WhatsApp group.
No, it is a Google Classroom created. No WhatsApp group I will be creating now. Okay, by today evening.
Actually, I'm asking for that Google Classroom code to join that classroom, ma'am.
Okay, then I'll send once again. Okay, already I have sent before, but I'll send it again today. So you join. All of you join there.
Yes, ma'am. Thank you, ma'am.
Yes. Just wait a minute.
Do we have to put the attendance in chat box?
Not necessary actually. Some are putting.
Yes, right. Yeah, that is why.
एक minute.
Madam, please upload the videos also, videos of the lectures also.
Yes. That I will do today, because it is taking time. So I didn't get last week actually the time to upload.
Okay.
Today I'll do.
Okay, madam.
Yes. So we will meet in the next week, and first assignment, try to complete it so that the burden will not be there, because at the end many of the students otherwise they do at the end for all the 3 assignments. That will be very heavy for them. So immediately after this, if you do, that will be fresh for you also, and many things are there in your mind, so you can execute also the solutions. Okay, so we will meet next week. See you then. Goodbye.
Thank you, ma'am.
Yeah, welcome.
Thank you, ma'am.
Thank you, ma'am.
Thank you, madam.
Thank you, ma'am.